Hi everybody. I know some students have gone to factoring and it can just be kind of difficult for them. So I thought if I could make a video describing all the steps, that could be helpful kind of for everyone. So when we come to a trinomial, which means we have like three terms like we do this problem up here, we always want to see if we can find a GCF, which stands for common factor. And we want to see the greatest common factor, like what number goes into all of those numbers and what variable if there is one. Well, with 32, 16, and 2, my only choice would be a 2 for a GCF because 2 goes into 2, 2 goes into 16, and 2 goes 32. So I pick the smallest number, and then if that number works, I write it over here, and if it doesn't, I just think about what other numbers go into 2. So if 2 wasn't my answer, 1 would have had to have been my answer because 1 would go into everything no matter what. The next thing you do is you have to divide your GCF out. So you put 2 in the front like this, and then you divide. 32 by 2 is 16x squared. Negative 16 divided by 2 is negative 8x. And positive 2 divided by 2 is positive 1. So we have like a new trinomial to work with. And our new trinomial is the 16x squared minus 8x plus 1. So we kind of almost ignore this one. We don't let it even exist anymore because we have a new form of it right here. Then you identify your a and your c. Well, that's the first number in your trinomial, so 16, times the last number, c, in your trinomial, positive 1. So in this one, it's kind of easy. 16 times 1 is just 16. It won't always be times 1. It might be something else. And then you identify the b value, which is the middle value of negative 8. And then I tell the students we have to find two magic numbers. These two magic numbers have to multiply to 16, and they have to add to negative 8. That can also be very difficult, although some students are able to do that very quickly. The way that works all the time is count to 5. 1, 2, 3, 4, 5. And then I'll show you a process we take. Now, if 1, 2, 3, 4, 5 doesn't work, you have to do 6, 7, 8, 9, 10, and continue until you find the ones that work. So to decide which one our magic number will be, we do 16 divided by 1 is 16. Well, sure enough, 1 and 16 multiply to 16. But when you add them, you get 17, which is not our answer. So now we do 16 divided by 2, and that gives us 8. And sure enough, again, 2 times 8 is 16, but 2 plus 8 is 10. That does not give us the 8 that we need. Then we do 16 divided by 3 and we get a decimal. 16 does not divide by 3, so we don't use it. Then we do 16 divided by 4. Well, 16 divided by 4 is 4. And if we add those, we get our 8 that we're looking for. But remember, we needed a negative 8. So the simple fix to that is to make this a negative 8. And in order to do that, you make these each a negative. So if you get the wrong sign, you just change the signs over here as well. And you have to change both the signs, whether it's positive to negative or negative to positive. These are our magic numbers that multiply to positive 16 and add to negative 8. This is probably the hardest part of the whole problem. Then we move to the box. The box gets 4 specific numbers. I'm going to zoom out so you can see where I'm going to pull them from. And the students are pretty good at filling the box in. So we have this 16x squared, that goes in this. So where my pen is, this 16x squared always goes in this top box. And then this plus 1, the back number, always goes in this bottom box. And then these two are our magic numbers. Our magic numbers go catty corner here and here. And it does not matter for those where they go. Even if they were different. I mean, if this was like, if our magic numbers were 5 and 6, we could flip-flop the 5 and the 6 or the 6 and the 5. But we were kind of lucky, at least we got a double negative here. Each of our magic numbers gets a single x. Now what we do is we kind of work our way down and find GCFs again, just like we did at the beginning of the problem, but we focus on like just 2 at a time. So the GCF between 16 and 4, well, what's the biggest number that goes into 16 and 4? 4. And if they both have a variable of x, we also bring down an x, which these both have a variable of at least 1x, so we always take the lowest one, which would be x to the first. Then we move over and do it again. Well, what number goes into 4 and to 1? Like, what divides? Like, can you do 4 divided by 4? Yes, but you can't do 1 divided by 4. So we want to actually think about our lowest number. So my GCF here, the greatest number that goes into both 4 and 1 is a 1. And since 1 does not have an x, we do not bring an x down. In order to know what sign you need to bring, you bring the top sign straight down, which would be a negative. Now we're going to do left to right. What number goes into 16 and 4? What's the biggest number? Now, I know 1 goes into 16 and 4, and 2 goes into 16 and 4, but 4 is the answer because 4 is the biggest number that goes into 4 and into 16. They each have an x, so we bring over an x. Next, we look at this one. So I have the exact same thing actually to look at again. What number goes into 1 evenly and into 4 evenly? The only number that goes into both of them evenly is a 1. And when we work our way left to right like we just did, we always bring over the leftmost side, so negative. We now have our final answer, and it's actually a double answer of 4x. Oh, you can't see that. Let me zoom out. Go. Our answer is 4x minus 1 from here, or here, it doesn't really matter, and another 4x minus 1. Students ask, is Miss Langeli, like, do I have to write this one first and this one second? The answer is no. You can flip-flop those. The only other thing we need is this GCF of 2 needs to plop down out in front. And that is how you factor a trinomial. I hope that was beneficial. If you are willing to sit there and kind of look through this problem with your student, or maybe you want to watch this and you're like, boy, I can understand. I think I can help my student with their homework. That would be fantastic. But I just wanted to make sure that I provided all the opportunities possible for our students to be successful. Thank you so much.